Hello, my name's Bob Smiley. I am a systems engineer at EfficientIP. And as hard as it is to believe, this conversation is going to be around DNS is dynamic. So here's some milestones, and not necessarily everything. These are the ones that are important to me and things that we'll be talking about as we go through this. But the original RFC 882 for DNS came out in 1984. And yes, kids, I was in the business back then. And it specified resolving and authoritative DNS, and that kind of morphed into authoritative DNS doing recursion, right? And we'll talk about that. 2005, I'm remiss if I don't point out DNSSEC, which is now fully functional across the internet. All of you people watching, if you want to do DNSSEC, which I highly recommend, it's supported completely across. Not related to DNS, in 2010, the zero trust security model. And hopefully that's the way we still like to build our networks, as far as not trusting anybody. DNS kind of got missed in this, so we'll point that out. The big one here for me especially is in 2013, the NIST published document 881-2, which is secured DNS. And they introduced a model of how to implement DNS, which I am still surprised I don't see more of, which we're going to get into detail on. Then in 2016, DNS over TLS was published. 2018, DNS over HTTPS, and we'll talk about both of those. But also in 2018 was Google launching 8.8.8.8, or commonly referred to as Quad 8, which is an AnyCast DNS address. Now, the reason I like to point that out as far as this piece goes is that after enterprises saw a wide use and a very good use of AnyCast DNS, the resistance to implementing it went dramatically down, right? They saw how well it worked out on the internet, how it just gets pounded, what the beauty of AnyCast actually is. And so enterprises got to the point to where they started not being so resistant to implementing AnyCast DNS. My NIST document, the thing that it says in there, and that's the big paragraph on there, section 3.2.2, is that any server is the very bottom line. Hence, it is not a good security practice to configure a single name server to perform both authoritative and recursive functions. So again, this came from 2013. In the last 6 months, there's been 7 CVEs published around DNS POOQ, right? DNS POOQ. That is one that absolutely takes advantage of servers that are doing both authoritative and recursive functions. There's also CVE 2020-25705 that is published around SAD DNS. And again, this is another one that absolutely takes advantage of authoritative servers that are doing recursion. So then what the NIST spec introduces, well, more than introduces, but a resolving layer. So as opposed to a client hitting an authoritative server and that authoritative server not being authoritative for that zone, it does recursion out to the internet. What a resolving layer does, the one that's in the middle, when those clients hit that recursive server, then it's going to forward to authoritative servers that it knows about, right? Those would be the ones that are inside of your enterprise, or it's going to recurse out to the internet. Now, there's quite a few benefits as far as this kind of an implementation above and beyond the security. right? So when those users right here in the middle hit this server and it goes to the authoritative, he replies back, this answer gets put into cache. The next bunch of servers, or the next bunch of clients that go to this server, are going to get that answer out of cache, right? And so what that does is it dramatically reduces the load as far as what that authoritative server is having to serve out. He's only going to be serving to the number of recursive servers divided by the length of the TTLs, right? So it's very predictable as far as how much that authoritative server is going to get hit, okay? The second piece on it is that the recursive server can be one manufacturer's and the authoritative server be another manufacturer. And I like to point this out as being layer 8 of the OSI model, right? Politics. So some people like to add records the way that they've been adding it for the last 10 years, right? They don't want to give up control of that, but you're able to move and put in all kinds of different functions and features at that recursive layer while letting them work on the platform that they're very comfortable as far as doing. So not only is this good as far as security goes, and even in the world today, in the last 6 months, it's still very applicable, but it's also good as far as flexibility and agility and what enterprises can do within themselves to address all of the new things that are coming.
So obviously this is something that's been done for, like you said, several years. This is best practice, kind of scalable DNS distribution and things like that. Speaking of distribution, do you guys support in this layer or another layer where I can distribute? I know you talked about AnyCast. I mean, we can do AnyCast in different ways. But do you do distributed DNS based on what zones or whatever I may be looking for, where I can swap out on the back end my DNS servers that provide those records, et cetera, et cetera?
We'll come to that in a couple of slides. I am still amazed at how many prospects that we go talk to that are still running authoritative servers doing recursion, right? And I'm not saying at this point in time that you have to do my product to be able to implement this layer. Everybody should be doing this. I really have a hard time understanding why I don't see this model as the default. Now, there are some exception cases, right? I will give you good example would be stores and local survivability, right? They still want to be able to get some DNS records, even if they can't get to their DNS servers and things like that. But there's ways to configure your authoritative server to not do cache, right? He still goes to that recursion layer and it's going to be holding all the cached records for anything above and beyond what you need for that specific. And that's the one, the one-off use case. And we do see that quite regularly. But again, there's ways to configure it so that that authoritative server is not caching entries that aren't 100% safe. Okay, so this is important and near and dear to my heart. This is one that we put together because of a customer request. And what the customer does is exactly what some of the people here are doing. They record video sessions, right? Not social conversations, but this kind of collaboration. And so to do the recording, things got really out of hand as far as having to add networks. And when this happened and their business went right through the roof, they had to, they added networks faster and quicker than what they could keep track of. So what they asked us for is a way to spin off what the DNS answers would be served based on an AnyCast address. So what we did, and this is my example here, and mine 5353 is my production networks. I get to all my internal zones and I get to recurse. 1.2.3.4 is my IoT. It gets a zone maybe inside, and it's only allowed to recurse to a very few places that I'm going to monitor and watch and keep track of. 9.8.7.6, that one is no internal zones. It's my guest network. The way that we did that initially, and we have a simpler way of doing it now that I wouldn't want to do in a worldwide broadcast. I would like to have the conversation under non-disclosure. But what we did is based on the source here, that if it came in on 5353, it gets these DNS views. If it comes in on 1234, it gets a different DNS view. All of that being done on the same server. So instead of 3 different servers with 3 different addresses coming in off of one server, using which AnyCast address that request is coming in, it gets assigned into its view. One of the other things that's absolutely wonderful about that, the resolving layer that we talked about earlier, this is where your security could be applied, right? The other one that we do quite a bit of, this resolver layer, this is where I record every DNS query that anybody's going to make, right? I've spent a couple of Saturdays now helping because FBI trying to track down bad people. So they wanted to see the DNS queries that these subscribers had made over the last 6 months, helping them do things like that. So I absolutely believe in that as well too. But at this layer, not the authoritative, this is where we can do all of the recording on that. So even though I have multiple networks, multiple everything, then I'm able to record all of that from one nice single location and have those logged messages set specifically to whatever SIM, whatever recorder that we want. So in case of an audit, weeks, months later, that we're able to pull those kind of records out. But this is, and this is why I kind of pointed out, we've done a good job on the security side with the zero trust model. This is almost a zero trust model for DNS, right? Because I can, within my DHCP options, I can specify what what the DNS resolver is going to be. And it's going to be one of these AnyCast addresses. So even within the same DHCP range by using ACLs, I can pick any one of these 3 AnyCast addresses to give to the client so I can treat their DNS queries absolutely differently. And then you'll see that we've done, and this is one of our best product differentiators, we've built to this resolving layer. So as I go through the next couple of slides, you're going to see where we're different than the other vendors that are out there on the out there right now in the DDI space, just because of what we've done after implementing the resolving layer. So the first is the smart architectures. So a smart architecture, as far what it does is we create all of the options, right? Everything, all of the definitions as far as DNS goes. And it's an arbitrary collection of servers. So I go in and define everything that I want as far as how those servers are going to behave. And then I can add servers in or out through the smart architecture. And so I can scale up and scale down at a moment's notice, right? Exactly what we kind of were showing earlier as far as what we can do with the orchestration. So what this means is that at any of those layers, I can add additional boxes. And if I don't need them, I can take them out. And because they're AnyCast, I can throw them pretty much anywhere and kind of point where my traffic's going to, because it's the routing protocol that's going to pick the closest AnyCast server. Okay. So as far as in the smart architecture in the past, it was more there for once I select what kind of architecture I want to build, right? master tertiary, many-to-one architectures as far as DHCP, how we put in the, how we help assist load balancers by making them optimal as far as multiple DNS servers behind them. So these are the smart architectures that the wizards will take you through as far as the configuration, multi-master, all of those. And then you're just able to add servers in and out, whether they are our servers or Bind servers or Microsoft servers or as Peter mentioned earlier, Docker containers nowadays, or even competitive servers can be added in or out of a smart architecture, right? So the whole point on this is that when you build it in this layer and we're protecting those authoritative servers from getting hammered because the queries are going through that resolving layer first, I'm able to scale that thing up or down at any rate or level that anybody wants to. And then one of the questions we heard earlier as well too, yeah, that includes the Route 53 as well too, that it can be added into a smart architecture. The next one is GSLB. Put GSLB on that resolving layer, on those ones that are capable of doing the AnyCast. The other thing, two other things that we do that's really slick with it is that resolving server doesn't have to be authoritative for the zone to be able to do the load balancing, right? That's pretty big. I believe that's unique to us, right? And then the other piece of that is that one of the load balancing algorithms that I use is latency. So walk all the way back, that the routing protocol is going to send you to the closest AnyCast address based on whatever algorithm that it's using. And then from there, I'm going to send you to the one that's responding quickest to my queries as far as which DNS record I'm going to return back, that's where the application goes to. So we do it as far as, that this has become pretty popular as far as manipulating the DNS records. Every account that I have, I make sure that it is part of their disaster recovery plan. I hate to see that the last thing they're going to go do is change their DNS records in a time of all heck breaking loose. So you use GSLB that as a record of last resort is your disaster recovery. So when something bad happens, you're not manipulating DNS records. You're letting the routing you're letting the GSLB send it to your disaster recovery place. But other things that it does help to distribute where it's going to. It does help to balance, apologize for the term, but balance the amount of traffic where it's going to, and it also allows you to create specifics as far as what gets returned back, right? So GSLB, we are a direct server return. We're not involved in response. We're just manipulating what DNS record gets returned based on a series of health parameters. So if a application goes down, it's not responding to my health checks, I'm not going to send its IP addresses back in my DNS responses. It's taken out of the pool. Instead of doing it at the authoritative server at the very end of the trail, we're doing it at the resolving layer, the first place that the client hits. It gives you a lot more agility as far as where you're going to respond back and what you're going to respond back with. The only caveat on this is that when I am load balancing the record that I'm not authoritative for, it has to be resolvable, right? So whether I resolve it by going to a server and getting an address back, it lets me know that the application's still active and working. If I'm unable to resolve it, then that application is down, okay? And that's the only caveat, but it's actually a good one because it's another health check. This is the Guardian. So what we've done with Guardian is we separated out the cache, recursion, and authoritative DNS functions, right? Bind does them all. We do it, right? Instead of Bind having to do it. And again, the number one that we get on that is that if the bind process goes down, it's real easy for me to switch to unbound. If bind and unbound and bind and NSD for the authoritative. So we split all that out. The other one that we split out is cache. And hopefully from our conversations today, you guys see that we are a very capable, competent database company. So we're keeping a tremendous amount of data, metadata, based on what's going on in cache. Everything from who's making the request to what zone they're going to, how long it's taking that zone to respond, even to and what the error codes are that are in there as well too. We're keeping track of things like a client and the number of queries they make that aren't in cache, or the number of responses coming back that need to be added in cache, or where they got added into cache, or even if I'm not allowed to add them in cache, or even if I'm getting an NX domain response. So there is quite a bit of information that you can derive from monitoring the cache. Now, hopefully you guys aren't so sick of me that we get invited back to the security discussions, and I'll go into a lot of detail as far as what security algorithms can be put in based on cache metrics. But for now, we're just saying that at this point, that resolving layer is now split off as far as what kind of functions and who's doing those functions. The other piece that it gives us is that at this resolving layer, that I can support multiple kinds of protocols, right? DNS over UDP with eDNS extensions. What I'm doing there is passing the originating client's information, so I can forward that through something like DNS crypt to Umbrella. So Umbrella gets to see the originating client, even though it's gone through a couple of DNS servers before it gets to it. Then we have the DNS over UDP and the DNS over TCP, right? And we do have customers that are doing that as well too. DNS over TLS and HTTPS, those are the new ones, right? But because they're hitting the resolving layer, I'm able to address those without having to go and change everything else that's running in the world. It makes it real easy to implement these kind of new protocols. So the first one, DNS over TLS, we saw that it's been out there before. It's a great way to do the last mile security, so that if somebody's sitting there eavesdropping in a coffee shop because you're using their Wi-Fi, this is what people use to make sure that that it's unique and encrypted as far as the DNS replies and responses. So we're seeing more than a little bit as far as implementations of this. I still believe that you should be you should be logging any of the transactions that are going through DNS inside of those firewalls, inside of the enterprise. So what we want to do is be able to decrypt this, then examine it, and then send it out, but keep it just as secure. Okay, next one is DoH. And these are the ones that are in DoH as of, I think, last month. And the one good thing about this right now is that they're off by default, right? And it just takes one software update to make them be on by default. Again, what this is last mile security. It's kind of like the Quad 8 as far as it's going to send it to a DNS server that isn't yours, right? So the DoH goes to whatever the browser is going to be pointing it to, and it's going to be encrypted and hidden from what you're doing. So the way for enterprises to do this is at that resolving layer, point all of those browsers to the DoH server that is part of that resolving layer. And then we talked about earlier as far as, I can scale up or scale down my resources real easily just by adding them into the existing smart architecture. So then as this gets more and more popular, more and more used, you can scale up or scale down, because it does take a lot more work to decrypt this DoH session, turn it into a DNS query, and send it out. And again, the reason that I put in at the very beginning, the DNSSEC, this is where DNSSEC comes into play. So the DoH gets decrypted at that resolving layer, and he works as a trust anchor out to the rest of the internet. So you still get the same level of security. You're just able to control it. And then last but not least, there's a couple of different implementations as far as this goes, right? So we've been pointing out the one here at the resolving layer in the middle that we're doing. The other thing that happens is if this becomes absolutely huge, right, as far as everybody wanting to do DNS over HTTPS all the time, everywhere now, we're able to put proxy farms in there the same way that we do load balance, or proxy farms for load balancers, just because of the decryption of the traffic becomes that much. The other one is maybe if he's not sitting on inside behind your enterprise on the firewalls, that he's sitting out on a cafe, that you have a termination point, right, for the DoH traffic on one of your servers, right? Rather than it going to that untrusted server outside, you give it an address to go to one of your trusted DNS servers. And then the same process that we're talking about here happens again, so that even if they're sitting out, if the client's sitting off premise and is doing DoH, you have a way to redirect them. So you'll see a lot of both positive and negative as far as DoH and the implementations of it. From our point of view, it's something that still has to be addressed, right? Still has to be looked at, because right now the browsers are nice. They aren't setting it by default, but that could happen the very next Tuesday night refreshes that they do. So we want to put in something that's able to address all of that. We need to be building with the resolving layer pointing to authoritatives. And then the reason that you definitely want to look at us, EfficientIP, and the solid server architecture, is that we've been building our products based on a resolving layer for more than a while now. Right? Our roots came from the ISPs, and we've brought that kind of ISP functionality into an enterprise at a very good price point.
I just had a quick question about architecture. Earlier we talked about how you guys use an optimized version of Bind. Do you guys distribute your records just through traditional DNS mechanisms? Do you use a database backend? Like, how do you store the zone records and distribute them?
There's multiple ways of doing that. We can do the primary tertiary as far as zone transfers, incremental or full updates as far as that. The other one is that within a smart, that it will be updating all of the individual servers through the management plane. And then when we go all the way back to the spaces and how I can architect that database, it's real easy for me, for example, to do a public and a private through two different spaces, as opposed to having to build different views. So you have your choice as to how you want to implement it. We can go the traditional zone transfer styles, or we can use the management plane to end of it to update all of the different servers within different smarts.